So now we'll discuss about the hard water and the soft water. Okay, when we consider as the hardness of water is most commonly is probably we are discussing if we consider as a rainwater in which we contain about some like acids like carbonic acids and what carbon dioxide which present in atmosphere. Okay, when it is allowed to get mixed with that. Okay, when this kind of the rainwater in acidic form which comes to the rocks. Okay, so due to that the layering of rocks is passed to get dissolved with the water, and when these compounds get allowed to dissolve with the rainy water, that the water content is converted into the soft to hard one. Okay, means like when due to the rain from the rocky region, we'll consider as a if this rain is falls on the limestone rock, okay, which is sedimentary rock. Okay, this is made up of like calcium carbonate. Okay, so due to that, this water get react with that one, and this calcium impurities get mixed with that, and that nature of water is converted into the hard. Okay.
Okay.
So in this case, we are considered as when any carbonic acid, and they are considered as acid rain, when it's mixed with the calcium carbonate, they are allowed to make the calcium hydrocarbon. Okay, so due to the presence of these ions, calcium and the magnesium ion in the water, which is convert the water makes it hard. Okay, so for that we will consider as a if we compare the soft water which can easily form the leather with the soap, but it is considered as a, if you are using the hard water, so the soap is allowed to get form the scum. Okay, means it is make a precipitate on the surface layer of the water. Okay, like the oily area is allowed to form. Okay, which is considered as a scum. Okay, it's like when you are using the soft water, and here you are taking the soap. Okay, so they are allowed to form leather. Okay, but if you are considered as hard water, and each you are allowed to make using the soap. Okay, so they are allowed to formation of scum. Okay, it's like undissolved precipitate layer which occur on the surface of water. Okay, due to that means this soap is now allowed to get dissolved in the water. It's make a oily surface layer. Okay, which called as an, so it is in the hard water the soaps are not working properly to remove any kind of the stains. So in that case, we are using like because in scum why it is allowed to get formed in the soapless detergent we are using to not form the scum, because detergents they are allowed to get, they are get convert the hard water impurities like calcium and the magnesium ion, they are allowed to get react with that and allowed to convert into the other substances like if you are using the N2SO4. Okay, so they are react with the calcium carbonate, and this allowed to formation of react with the calcium sulfate. Okay, so this component is get broken down while you using the detergents rather than soap. So due to that, this calcium and the magnesium impurity present in the hard water that will allow to get dissolve it out, and easily you're converting your hard water into the soft one. Okay, till now any doubts, any confusion?
No. No.
So in will consider as a normally the range what we are consider for the hardness of water, primarily if you having around 0 to 100 mg per liter as a calcium carbonate is present in the water. Okay, so its nature is considered as a soft one or moderate soft. If this ranges get increase around this comes to 100 to 200 mg per liter. Okay, so that is considered as a slightly hard water. Okay, if we'll consider above than 200 mg per liter of calcium carbonate is present in the water, so they are considered as hard to weigh. Okay, so that is the range we are considering. So on the basis of that, in these two categories, the soap most probably get working. But in that case, if we are considered as for this hard, we need to be use the detergents. Okay. Now, how we can measure this hardness of water? For that, one way we are using that is considered as a titration. Okay, titration with the soap solution. Okay. I'll consider as a we'll take the known volume of water. Okay, and we put in one conical flask. Okay, about 100 ml or 50 ml we'll take it. Okay, and then the soap solution which is made, we are fill the soap solution the burette we are filling with the soap solution. Okay, then the mixture which is allowed to swell is helps to allow to form the lid. Means one side you having the soap solution, one side you having the water. Okay, so one drop by drop you are adding this one. When at a particular point this soap solution is allowed to form the letter in the water. Okay, that particular point the reading in the burette we are noted. On the basis of that, how much volume is needed means that water hardness is that much high. Okay, if within a small amount of the soap solution the water become lighter, so means that the hardness of water is less. If it's require more soap solution to the water become lighter and completely get dissolved in the soap solution get completely dissolved in the water, so it means the hardness is more. Okay, so it depends on the how much amount of the soap solution get consumed by the water to become liquid. Okay, so in that case we are considered as approximate. Normally if you are using the distilled water, okay, so there is only in a one drop you will getting the reading, because distilled water is pure soft nature of water, in which if you are adding one drop of soap solution, so they will become permanent lid. Okay, same as you are getting two more samples here. A reading is comes 6.4. Okay, means around in the burette reading which nature comes till 6.4 of the soap solution get consumed by the A, and the B consume around 3.8. So means A is more hard water as compared to B. Okay, it's less hard, and that one is very soft. Okay. Yeah. So on the basis of that consumption of the soap solution by the water sample, we can getting the what is the nature of water is hard, moderate hard, or completely very highly hard. Okay. So on the basis of that, this is the how much on the basis of the hardness we are dividing in the category. Now the hardness is also it's like time period basis we can consider as, and water concentration they have, they're divided into two types. One is considered as a temporary hard water, okay, and one is considered as a permanent hard water. Okay, temporary hard water we can easily get converted into the soft one by simply you are boiling the water. Okay, means you are taking the water in one utensil and you are allowed to boil that one. So all the hardness is get settled down in the salt form, any impurity which is present it settle down at the bottom, and the water become convert into the hard to soft one. But the permanent water, by boiling, it's not allowed to remove the hardness of the water. So for that case, we need to be use some other kind of the techniques. Okay. So most commonly, that will consider as, for example, if you are having this kind of test, you are done with the distilled water and A and the B1. Okay. The same category if you are done. Okay. So while boiling and while adding the solution, for distilled water reading you will get 0.1. Means this is a completely soft water. Okay. And A, before boiling, the reading comes 6.4. But this same water, after boiling, again you do the same type of titration, you see the reading get reduced. It comes 1.6. Okay. But in the same case, if you are using the B1, once you're taking the test before boiling, its reading comes 3.8, but after boiling also you see that it's get the same reading. Means the hardness of A is not permanent. Okay.
Yeah.
But in the case of B, it's a permanent hardness. Okay. Due to that, because before the boiling and after boiling, there is no change occur in the reading of the sample B. Okay. On the basis of before boiling, this is more harder, but after boiling, the B become more hard water as compared to A1. Okay. So on the basis of that, these two categories can be distinguished from each other. Now, on the basis of that, when we are considered a simply term, if we consider as a temporary hardness. Temporary hardness means what? We will consider as some you having in water, like some hydrogen carbonate ion present. Okay. Most commonly the hydrogen carbonate ions in salt form, if it is present, so they are what? Whenever you are giving the heat, so they become ionized and easily break it into hydrogen ion separate and the carbonate ion separate. Okay. Is here you have HCO3 minus, when you are giving heat, so it will break into H plus and CO3 2 minus. Okay, means it become ionic, and due to that ionic, before boiling, the which component is not dissolved in the water, but this carbonate component after boiling is allowed to get completely boiled water is allowed to get react with the calcium and the magnesium ions which is present in that, and then they will allow to formation of insoluble precipitate. Okay, means now this carbonate ion react with the calcium and magnesium and allowed to convert into the magnesium carbonate and calcium carbonate. Okay, and once this magnesium and calcium carbonate allowed to form, they will form a insoluble precipitate, and which is get completely settled down at the bottom. Okay, and the upper side the soft water is remain. Okay, means all the hardness come settle down at the bottom. Okay, so this type of the hardness is occur if in the water, so which is considered as a temporary hard water. In the case of permanent, what will done, the water, it do not contain the hydrogen carbonate type of bodies. They'll contain the sulfate ions, and when you are giving heat, so this sulfate ion is not get decomposed. Okay, means they are not get completely degenerate and completely break down. Okay, in this sulfide ion forms. Okay, so due to that, and they are by the giving heat, if they are not get decomposed, not break down, so after heating also they are not get react with the same calcium and the magnesium ion. So they are not reacting with the calcium and magnesium ion, so they are not allowed to form the undissolved precipitate. So means this calcium and magnesium ion impurity is get stay with the water even after boiling. Okay, we'll discuss about that, the benefits and the drawback. What kind of the benefits we have and what kind of the drawbacks we have of the hard water. Okay, primarily if we'll discuss about the what's the benefit we have as compared to the soft one. Normally we will see on the basis of the taste. Okay, for example, if like calcium compounds, if it's present in the water, it's allowed to improve the taste of the water. Okay, second one, this calcium which is present in the water, that is allowed to get develop and they maintain the bones of the teeth, because they are made up of maximum amount of the calcium component in the potassium. Okay, and they are also helps to reduce the heart disease, because the minerals contain so many minerals, calcium and magnesium, which is get provided to the body with the content of hard water. Okay, and next one, if we discuss about the drawbacks, we are using, because if we are having the hard water, so we need of the more soap content, soap solution to produce the litho. Okay, so that's why it's become need more completely have a little bit expensive, because we need a more soap solution to remove the hardness of water and convert into the litho form. Okay, because that same things happen with the permanent and temporary also. Second one, if we'll consider the scum is get produced. Okay, so this scum is gas spoil the vessel when we are consider as a on the, like is make a layer on the showers and all, consider as a, okay, like whitish layer is allowed to form on the surface of the any kind of the taps and the showers. Okay, so then we'll consider as a next one, we are consider as this temporary hardness which is present in that one. In this case, which is considered as a any kind of the kettles we are using, any kind of heating systems we are using, the efficiency of that particular like utensils and all, due to the presence of the mineral with that, they're reacting with the utensil and the metal, so their efficiency gets reduced. Okay, because they are having the high amount of the limescale, because calcium carbonate CuCO3 is present in that, and they will get completely a make a layer on the surface of that any kind of the kettles and we are using to boil the water. Okay, so under this ketting is allowed, completely a layer is allowed to form. This, if this kind of the hot water we are get thrown out in the pipelines and the boilers, so they are also get affected by that. Okay, so it means when you are heating the heat the water, you, if you're having the hardness, either it is temporary in the form, so you need to use the so much amount of the energy to heat up the water, to boil the water. So again, this removing cost of removing the hardness, we need to give the more cost in the form of energy, also in the form of using the soap solution, the better detergents also. Okay. And sometimes when this kind of the limestone is make a layer on the surface of the taps in the shower, sometimes they will allow to get block the pipelines also. Okay, because it is allowed to make a salty layer on the surface of the pipelines. Okay, so sometimes when this kind of the layer when is formed, this can damage the pipelines and the breaking down, that kind of the problems is up. Okay, so that is like some benefits and the drawbacks of it. Now, in a temporary hardness, we know we can remove it out by the boiling. But one time, if you are having the permanent hardness, so how can you remove this permanent hardness? Okay, you can remove that permanent hardness by involving that component in the water, which can easily get react with the calcium and the magnesium ion present in the water. Okay, once that ion you are adding, which can be able to react with the calcium and the magnesium ion present in the water. So again, as same as in the temporary hardened water, they are allowed to form the calcium carbonate and magnesium carbonate and get settled down in the form of precipitate and undissolved form. So these things is happens. The same things happen with the permanent hardened water. Okay, but here we need to be added the iron form, which can be react with the calcium and the magnesium ion present in the water. First method we can use by adding the sodium carbonate. Okay, Na2CO3. Okay, once you added this one in the hard water, so once it get dissolved in the hard water, so what will happen? This sodium carbonate, which is normally in general name is called as washing soda, so it is able to remove both permanent and the temporary hardness of water. They are allowed to get soluble, so means they will allow to get breaking out into CO2, get break into 2Na plus and CO3 2 minus. Okay, again this carbonate ion now able to react with the magnesium ion and the calcium, which is present in the hard water, and they will allow to form magnesium carbonate and the calcium. Now they can again form the undissolved precipitate and can be separated out from the hard water, and water get converted into the soft in nature. Okay, so that is the first method we are considered as a in which water completely get softened, no longer contain any kind of the calcium and the magnesium ion. So now it get more easily leachable and with the soap. Okay. So most commonly we are using this is allowed to form the lime scale precipitate. By the filtering we can separate it out. Okay, and then we can use the soft water for our application. Next one method we are using that is considered as a ion exchange column method. Okay, this is like in commercially purpose we are using this technique. In the commercial water softener we are most commonly use the ion exchange, that is considered as a resin. Okay, this is most commonly the substance is made up into like beads. The small like a glass piece is available like this it is present. Okay, and this is packed into one column, okay, like this. Okay. In this you have in complete base form. Okay. From upside you are adding the hard water. Okay. In which this is the ions are the present. Okay. So they are allowed to the calcium ion from the water. Like here you having ion exchange column which contain the sodium ion, right? And the water contain the calcium ion. Now due to the presence of this raising base, what will happen? This sodium ion is get replace the calcium ion, and now in water sodium ion is allowed to mix, and the calcium ion with the ion exchange column is get attached. Okay, means both places get exchange. So due to that, now from the end of this column, which water you are getting, in which instead of calcium ion you having the sodium. Okay. And this sodium ion in the form of precipitate get easily get removed out. Okay. So in general way, what we are doing, we are taking one ion exchange column, and then afterwards from the completely plumbing system, there continuously the hard water is adding from the top part in this resin base which having the sodium ion that attach with the hard water, and calcium and magnesium ion is swept out by the adding in their place sodium ions. Okay, so means now which sodium ion is attached with the resin, this is removed it out, and in that place calcium and the magnesium ion get attached. Okay, now this sodium ion get mixed with the water, and afterwards the another side of the water you are getting in which no any kind of the calcium and the magnesium ion impurity is present, only it is having the sodium ion concentration. Okay. Then often we are considered as a, when we consider any kind of the calcium and iron which is already get saturated, so they are allowed to get again regenerated by adding the sodium chloride. Okay, because when we are adding the salt form for that, so the sodium ion it contain replace the calcium and the magnesium ion in the base, and again the sodium chloride is like cheaply available, so that's why this technique is not so much expensive, so it is considered as a very convenient and cost effective matter for us. Okay, means like completely resin, when it gets like saturated by the calcium and the magnesium ion, so what we'll do, we are adding some amount of the salt in that. So again, due to the salt content are present, they are allowed to get again this calcium and the magnesium ion impurity get replaced by the sodium. Okay, Na is attached here, and this is allowed to form MgCl2, and the CCl2 is get separated. Okay, and due to that, because the NaCl cost is not so much high, so this method is so much cost effective for us to remove the permanent hardness of water.